Hello and welcome to lab. Today we're going to do experiment 15, Introduction to Acids and Bases, pH, molarity, and Ka, Kb. The first step in this procedure is to calibrate the pH meter. So I'm going to hook that into my power supply, and the instructions for this are in the appendix of the lab manual. And I'll connect my electrode. This one also has a temperature control. I'll hit setup, enter, setup, and I'll select the range that I need. And again, this is all in the lab manual. The first thing I'll do is I'll shake the electrode off and then normalize the electrode with my first buffer solution, pH 4. And I'll just let that sit. Looks like I'll need to hold it a little while so it doesn't fall over until I get the S in the display. And then I'll press the standardize button. And the meter will calibrate itself to what a pH 4 should look like. Once I see the 4 in the display, I'll shake it off, pour my pH 7 buffer over the electrode and let that sit in the pH 7. You can see it sitting in the pH 7 buffer. Once I see the S in the display, I'll hit standardize, and the meter will calibrate to a pH 7. I should see 4 and 7, which I do, in the display. I'll hit the enter, and now my pH meter is calibrated. Just kind of leave it sitting there for a minute. The next thing we need to do is to normalize and then fill our sodium hydroxide burette. I'd like you to do that. I'd like you to read the initial burette reading of the sodium hydroxide. I've also obtained 50.0 milliliters of acetic acid in this 250 milliliter beaker. In the next step, I'm going to shake off my pH electrode and just kind of blot it with a paper towel to remove any of that pH 7 buffer solution. And I'm just going to leave the cap on. Doesn't make any difference. I'm going to stick it in the acetic acid solution, and then I'm just going to let that stabilize a few minutes before we take our initial pH reading. Now we can start our titration. I'm going to add a few drops of phenolphthalein and just give this a stir. And I'm going to titrate in 1 milliliter increments. The milliliter reading is 2.50.
pH is 3.29.
The milliliter reading is, let me give this a stir, 3.70, and we'll wait for the S to appear.
So pH is 3.70.
That's unusual, but fun. The milliliter reading is 4.50.
pH reading is 3.83.
Milliliter reading is 5.50.
pH reading is 3.99.
Milliliter reading is 6.50.
pH reading 4.11.
Milliliter reading 7.50.
And the pH reading 4.23.
Milliliter reading 8.50.
pH 4.33.
Milliliter reading 9.50.
And pH 4.46.
Milliliter reading 10.50.
pH 4.57.
Milliliter reading 11.50.
pH 4.68.
Milliliter reading 12.50.
pH 4.79.
Milliliter reading 13.50.
pH is 4.89.
Milliliter reading 14.50.
pH 5.05.
Milliliter reading 15.50.
pH 5.18.
Milliliter reading 16.50.
pH 5.43.
I'm going to expect a big jump in pH pretty soon here. Milliliter reading 17.60.
pH 5.75.
Milliliter reading 18.50.
pH 6.38.
And now we're definitely past the equivalence point, as you can see with a bright pink solution. Our milliliter reading is 19.50.
And pH is 11.70.
And I think we need to go to 2 or 3 readings over 12, so I'll continue with this. .60.
pH 12.07.
Milliliter reading is 21.50.
pH is 12.22.
And we'll do one more. Excuse me, 22.60.
pH 12.33.
And that should complete our titration for the acetic acid and sodium hydroxide. You can now graph your data and then answer the questions that follow on that data sheet. In the next part of the experiment, we are going to titrate ammonium hydroxide with hydrochloric acid. I'd like you to obtain the hydrochloric acid solution, normalize, fill the burette, and read the burette, and I'll obtain the ammonium hydroxide solution. I'd like you to read the initial burette reading for the hydrochloric acid and also the initial pH. We're going to titrate as before. The indicator for this one is bromocresol green. Add a few drops of that. And it is a beautiful light blue color. And we can start our titration. The initial next burette reading is 4.25.
pH is 10.15.
The next burette reading is 5.00.
pH 9.97.
milliliters.
pH is 9.80.
milliliters.
pH 9.69.
8.00 milliliters.
pH 9.59.
9.00 milliliters.
pH 9.50.
10.00 milliliters.
pH 9.41.
11.00 milliliters.
pH 9.32.
12.00 milliliters.
pH is 9.21.
13.00 milliliters.
pH 9.09.
14.00 milliliters.
pH is 8.95.
15.00 milliliters.
pH is 8.76.
milliliters.
pH is 8.55.
Milliliters.
pH 8.19.
Milliliters.
pH is 3.30.
As you can see, we've passed the equivalence point. Our indicator has changed to a light yellow color. We need to go to 3 readings below 2. $19.00 milliliters.
pH is 2.01.
$20.10.
pH is 1.71.
$21.00.
pH is 1.58.
And one more reading and we'll be done. 22.00.
pH 1.49.
All right, now you can graph this data and complete the calculations on this data sheet. And we might as well clean up here before we proceed to the next part. We'll rinse both burettes with DI water to clean them out, and then we'll flip them and open the stopcock to signify a clean burette. In the next part of the experiment, we're just going to determine the pH of some simple household solutions. The first one is vinegar. And the second one is ammonia. So I'll normalize the electrode with the acetic acid solution, and then I'll put the electrode in that solution and let it stabilize. Now we can do the same thing for our ammonia solution. Normalize the electrode, and then insert the electrode into the solution, and we'll wait a little while for that pH to stabilize. Now that we're done with the experiment, we can clean up. Be sure to rinse the electrode off with a little bit of DI water before putting it back into the storage bottle. And you can unplug your meter and Be sure that your electrode is stored upright in plenty of the KCl solution. I usually like to put it in the one of the angles between the gas or the vacuum valves. Keep it upright. Both of these burettes have been rinsed with DI water. Now they're flipped and the stopcocks are open, signifying a clean burette. We'll dump all of our solutions. And we can put all the glassware kind of in the center, ready for the next group. Thank you for being my lab partner today.